underwater welding comes as a surprise to many. This is because welding needs a flame or an arc, either from burning of a gas or from electricity, and water does not go well with the flame arc. However, underwater welding is quite possible, and it is a serious occupation for highly qualified welders, with some diving background and a decent pay. A job that involves a great deal of skill and expertise. Today, I would like to focus upon the two different types of underwater welding. There are two main types of underwater welding: wet welding and dry welding. With this in mind, we want to explore the questions: how does underwater welding work? How do welder divers perform welding tasking at elevated pressures, and in particular underwater? Underwater welding was invented in 1932 by the Russian metallurgist Konstantin Krenov and has since been used for repairing ships, pipelines and offshore oil platforms. Over the years, there has been significant advancement in this underwater welding technology, such that even nuclear power plants involve certain underwater welding tasks. Wet welding is a technique that involves creating an electric arc between an electrode and the material being welded. Known as shielded metal arc welding, SMAW, this method is both cost-effective and versatile. Before commencing the weld, underwater welders must meticulously inspect the area for any obstructions or potential safety hazards. It is essential to maintain clean electrodes to ensure the quality and safety of the weld. To protect underwater welders from the risk of electrocution, a thick layer of gaseous bubbles is generated around the electrode. These bubbles form a protective barrier that shields the welding area from water, corrosive gases, and other oxidizing substances. On the other hand, dry welding, also known as habitat welding, utilizes a hyperbaric chamber to perform welding tasks underwater. The process begins by creating a seal around the structure needing welding. Connected hoses then flush out the water, replacing it with a gas mixture, typically helium and oxygen. Once the water is fully expelled, the hyperbaric chamber is pressurized to match the underwater depth, preventing decompression sickness. The specific dry welding techniques employed depend on the size of the hyperbaric chamber. There are four main types of dry welding methods: pressure welding, habitat welding, dry chamber welding, and dry spot welding. Additionally, wet welding techniques like shielded metal arc welding, SMAW, and flux cord arc welding, FCAW, can also be applied in conjunction with dry welding methods, enhancing the versatility and effectiveness of underwater welding operations. Regarding tools and equipment, underwater welding requires specialized tools and equipment, including 1. Diving gear. Welders wear diving suits, helmets, and life support systems to ensure safety while working underwater. 2. Communication systems are integrated into the helmets for constant contact with surface support teams. 3. Welding equipment. Waterproof electrode holders, welding rods, and power sources designed for underwater use are essential. For dry welding, hyperbaric chambers and pressurization systems are required. For inspection tools, non-destructive testing tools, such as ultrasonic testing and radiographic testing, are used to inspect weld quality and detect defects. Lastly, safety is paramount in underwater welding due to the hazardous environment. Key safety measures include 1. Training and certification. Welders undergo rigorous training and certification to ensure they are skilled in both diving and welding techniques. 2. Risk management. Comprehensive risk assessments and safety protocols are established for each project. 3. Emergency procedures and equipment are in place to handle potential accidents. Lastly, health monitoring. Regular health checks and monitoring ensure welders are fit for the physically demanding and high-pressure underwater environment.